All right, so we are writing equations for ellipses with each of the following characteristics. So we're using what we know about ellipses and general equations to create an equation. So the one thing is that whenever we're presented with one of these types of problems, we need to know three pieces of information. We need to know the center, h and k. We need to know the value of a, and we need to know the value of b. So the fact that we have our major axes is from negative 6,2 to negative 6,8. We can kind of think, okay, well, this is a negative 6,2, and then this would be negative 6,8. The x-coordinate does not change, it's the y's, which lets us know that this is going to be a vertical ellipse. Okay? Because the x's don't change, but the y's do, then our major axis is going to be vertical, meaning that our ellipse is going to be vertical. Which means that our general equation for an ellipse, the a squared is going to be underneath the y's, and then the b squared is going to be underneath our x's, because again, it is a vertical ellipse. So, what is the center? Well, from the endpoints of the major axes, all we really need to do is find the center.
At this time, we need Tanner Massey in the foosball room. Tanner Massey, please make.
Sorry, I meant to say we need to know the midpoint between these points, okay? So, to figure out what point is exactly in the middle, all we do is we take our x's, we add them up, divide by 2. So then that would be a negative 12 over 2, which is a negative 6. And then 2 plus a negative 8, that would be a negative 6 over 2. So then that would be a negative 3. Our center is located at negative 6, negative 3. So then we can go ahead and replace, oops, didn't mean to do that, super good. So then that means we can replace our h and our k with those values. So it's going to be a plus 6 and then a plus 3. To find the value of a, since we know that the major axis is from negative 6,2 to negative 6, negative 8, that is a total distance of 10 units. Okay, basically just find the distance between those 2 points. Because our major axis is equal to 10, that means that 2a will equal 10. Dividing both sides by 2, that means that a will equal 5. So then to plug it into our formula for our equation, a squared is going to be 25. So then this is going to be 25. To find b, to find our b squared, we know our minor axis goes from a negative 3 to negative 3, or sorry, negative 9, negative 3. That right there is a total of 6 units. So then 2b would equal 6, because again, from before, the length of the minor axis is equal to 2b. The length of the major axis is equal to 2a. So then b would equal 3. So then b squared equals 9. And so knowing that information, we can determine the video. So in that way, we can determine that our equation for this ellipse is going to be x plus 6 squared over 9 plus a y plus 3 squared over 25 equals 1. So we're using what we know to go ahead and create our equations. And you don't necessarily have to draw a picture of it, but sometimes for those people who are visual people, maybe drawing these points or drawing an ellipse can actually be very helpful. Now vertices are located at negative 4, 4 and 6, 4. So let's see, that's negative 4, 4 and 6, 4. Remember, vertices are at the ends of our major axes. And so since we know that these are our vertices, we know that this is going to be a horizontal ellipse. If our x's are the ones that are changing, then we know that it's going to be horizontal. Now our foci are located at negative 2, 4. So negative 2, 4 and positive 4, positive 4. All right? And so again, since our x's change, we know that it's going to be a horizontal ellipse. So let's go ahead and let's find our center. All right? Let's go ahead and let's find our center. Since this is horizontal, our a squared is going to be underneath our x's. Our b squared is going to be underneath our y's. To find our center, we're going to take the x's, add them up, divide by 2. So that's going to be a positive 2 over 2, which is a 1. We'll do the same thing with our y's, but since it's basically the same number, it's going to be that. So our center is at 1, 4. So h, I'm going to plug in 1. K, I'm going to plug in 4. To find the value of A, remember A is associated with our major axis length. Okay. To go from negative 4, 4 to 6, 4, that is a total of 10 units. So 2A is equal to 10, which means that A is equal to 5 because we divide by 2. So then A squared is going to be 25. Now to find our B. We don't know what our covertices are, but we do know where our foci is located. Now remember, we find our foci by adding the value of C to either the x-coordinate or the y-coordinate of our center. So the distance between the foci is actually going to be equal to 2C, okay? So 2 times either A, B, or C represents the length of those respective axes there. So from focus to focus, that's going to be a length of 2C. So 2C is going to equal 6. To go from negative 2, 4 to 4, 4, that is 6 units. So if 2C is equal to 6, that means C is equal to 3, which means that C squared equals 9. Why do we need to know C? Well, there's a formula of C squared equals A squared minus B squared that I can use to help me figure out exactly what B squared is going to be. So I plug that in. I subtract 25 over to get a negative 16 equals a negative B squared. So then I divide both sides by a negative, and B squared equals 16. So my equation for this particular ellipse is going to be what you see here in the pink.